The Electric XGB has multiple ways to initiate motion. Complex moves and sequential moves will use the position data table in the XGPM software to define these moves, and then use various function blocks in the XG5000 programming software to call them up. However, the XGB also supports a direct start function, which allows us to define the move directly from the logic in XG5000 without referencing the position data table. The XPM DST function block can be useful for programming numerous moves with a single function block, as the direct start parameters may be altered between function block execution. This allows nearly unlimited simple moves without using up a lot of memory and processing power. However, they do have some limitations. For example, the direct start function will not work for multi-axis interpolated moves or multi-move sequences. These will require the use of the position data table. For this example, I have the XEM Motion Training project open. This file is available to download from the XGB Interactive Guide at AutomationDirect.com. It is designed to allow us to simulate a 3-axis motion system without having to have any physical hardware attached to the CPU. We have already configured our axes in the XGPM software in a different help topic. Please refer to it and the product documentation for more information on axis configuration prior to attempting any motion. We also have powered up the axis in our logic and turned the servos on, which are figurative in this example. Most of the motion profiles in this project are interpolations using indirect start function blocks. However, we do have a direct start function block for each of the axes. If we go to the Axis 1 motion program and go to line 90, we see that we have an XPM DST function block. Currently, we don't have enough columns to see the entire line of code, so let's add a few columns to our programming environment. You can go to View, Change Columns, Increase Columns, or we can go to the icon of a series of cells with arrows pointing outward. Now if we look at line 90, we see that if we are commanding an absolute move, and the program is in absolute mode, and axis 1 is ready, we will request a direct start. This direct start will command base 0, which is our main PLC base, slot 1, which is the onboard pulse motion controller, and axis 1, which is the x-axis in our system. Let's move to a target of 1,000 pulses at a speed of 500 pulses per second. Our dwell time will be 0 when we get to the end of the move, and we aren't using the mcode function for this move. Our control value is currently 0, which corresponds to a position move. We could set this to 1 for a speed move, which is a velocity-based move that requires the use of the XGM STP function block to stop motion. This function block is covered in another help topic. We could also set this value to 2 for a feed move, which is an incremental move where the sign of the target position determines the direction of rotation. Please refer to the product documentation and help files for more details on each. Our absolute or incremental bit is showing 0, so this will be an absolute move. If this was a 1, our move would be an incremental move made relative to the axis's current position. Finally, we are selecting 0 for our XL and D cell. If we leave monitor mode and double-click on the top cell of the function block, it will open the function/function block pop-up window. If we click on the help option for this function block, we see that the XL and D cell selection being set to 0 refers to using preset 1 for XL and D cell times for this move. These presets are configured in the basic parameters for this access in the XGPM software. We cover setting these parameters in a different help topic. In our case, XL times 1 and D cell times 1 are both set to 500 milliseconds. Let's trigger our move and watch it execute in the Trend Monitoring tab. First, let's go out of monitoring mode so we can avoid filling our trend with empty data. We will then go to Monitor, Trend Monitoring, unselect View Bit Graph and Display XY Graph, and add Pause 1 CurPause to our trend graph. This is a system flag variable that displays the current position of axis 1. We will leave the sample setting values at the defaults and click OK. If we were still in monitoring mode, the trend would begin to fill with empty data, so it is important we left monitor mode prior to adding the variable to the trend. If we go back to the Axis 1 motion program, line 90, we can go back into monitor mode, make the Axis 1 command.direction absolute move bit true, and then observe the motion with the trend monitoring. We see the X position go to 1000 and hold there. If we go back to the direct start function block and change the target back to 0 and the speed to 100, We can then make the command bit true again, and watch the move with our trend monitoring. We see the axis move back to 0, and it happens much slower since we altered the velocity of the move. The direct start function block is limited, but it is a very powerful and simple way to perform basic single-axis motion with the LS Electric XGB PLC.